Hello, everybody. My name is François Ward. I'm the engineering lead of front-end infrastructure here at HubSpot in Cambridge. And I'm here to talk about how to make front-end developers, first-class citizens in your organization or your company. Now, this is a presentation that I gave at the ReactJS Boston meetup at WayFair. And unfortunately, while I recorded it, I lost the audio. So I'm going to try to record it again. It might not come out quite as good because I don't have an audience to respond to. But at the very least, for anybody who could not attend or who wanted to listen to it again, it should give you some of the context and the information that I talked about during my presentation. All right, first, before we move on, some warning. These are not copyright warnings like there would be in a movie, but I want to warn that this talk contains opinions. Now, it's not uncommon for talks at conferences or meetups to not be completely factual and often have opinions of the speakers, but this talk contains basically nothing else. This is how me, François, think how an organization should handle front-end development, and there are suggestions on if you see gaps or things you don't agree with or don't like in an organization, you might use this to start discussions or bring up topics with your team on how to potentially make things better. If you do things completely differently or completely the opposite of the way I see it, it's okay. If you think it's working for you, keep it that way. If it's not broken, don't fix it. And if you completely disagree with me, that's totally okay too. There's a lot of ways to make software development work. There's not one true way. It's just a whole set of trade-offs. Yeah, so with that, let's get started. Let's start with a couple of codes. All the codes I'm going to show are real. I've either heard them myself, most of them recently, or I found them while working on this presentation on social medias. I paraphrase them. The goal is not for people to Google them and start pointing fingers. So I tried to change them, reworded them a little bit. But yeah, let's see if they make you cringe as much as they would make me. HTML, CSS, JavaScript is the worst thing to have ever come to the world of software engineering. We're starting light here. Why do we even need dedicated front-end development? It's just so easy to do. Why are front-end devs paid as much as back-end developers if they have less responsibilities, right? The front-end ecosystem is just so unstable. There's a new framework coming out every day. And honestly, a couple of years ago, I'd probably agree with them. This person failed our back-end interview. Let's just hire them as a front-end dev because they'll be able to do that. Back-end applications have so much more challenges than front-end one. They have architecture, scalability, performance, security, and all these things to think about. Front-end has none of that. Front-end development is just not real programming. Short and sweet. This one is a review of a pretty famous, pretty large company on Glassdoor. Again, the goal is not to point fingers or shame anybody, so it's paraphrased, but it's real. Front-end developers are second-class citizens here. You will not receive the same salary, the same opportunities, or respect as the others. You might enjoy working at this company, but don't join as a front-end dev. Now, what does this mean? Like, what kind of organization or groups or culture creates this kind of sentiment? Well, a company where front end is not a first class citizen or it's not taken seriously, is frequently companies where back-end development is front and center. Maybe like the product really started on the data, on the algorithm side, and the front end was not really seen as a primary part of it. Maybe it was slapped on it later because they wanted to sell their product, and if the product is not a bunch of APIs, which is a valid business model in some cases, but if like it's an average user, they needed a front end, and maybe they only thought about it after the fact. It's going to be organizations where resources are not allocated in a way that supports state-of-the-art front-end development, where R&D for front-end or spending time to push front-end applications to the limit of what technology allows to build the highest quality product is just not a primary focus. These are going to be organizations where if you're a front-end first developer, like someone who specializes in front-end technology, like React, JavaScript, CSS, design, all these things, you might not be able to thrive because it's expected of you that you're going to wear all these other hats of a backend developer at the same time, and you won't be able to push front-end technology as far as you can, or you might not even be taken seriously for wanting to do so. Unfortunately, organizations like that are quite common, and sometimes it's okay. Maybe it's the best thing for them, but as front-end developers, it might not be the best place to be or the most enjoyable place to work at. How did we get there, though? Why is this so common? Why is this sentiment so frequent and hurts so much that almost all of us have heard some of these if we've been front-end developers for a long time, or if you are a newer front-end developer trying to join the industry and you caught wind of that? Well, first, when you think about it, front end really used to be the input of the back end. And by that I mean, like, if you go back in the 90s or something, um, like apps like desktop applications or terminal based apps uh, were very much the norm, and there really was no distinction between the two. If you were to build, let's say, an application in Visual Basic 6 or something, you were maybe pulling the data from a local store or from an API, and you were maybe crunching the numbers a bit, doing some calculation, running some algorithms, and then you needed to show it. You just build a form or drag a couple of buttons, put in a grid, and then you'd show it because you needed to make that data useful. But it was really the same person who was building one and the other. Then when web development came in, environments like Perl and CGI or PHP in the old school days, well, when you were outputting HTML to be consumed by the browser, it was very much like a print or an echo statement or something like that, and you were printing HTML, and your server would pick that up and serve it to the browser. So the HTML and JavaScript part were very much just output of the backend code. Um, there were tools that were trying to abstract that away that were born because that wasn't great. There are tools like ASP.NET Web Forms back in the old days, or things like GWT for Java, that tried to make it that building a web application was very similar experience to building these desktop app where you'd only really have to think in the backend language. If there was a lot of data involved, a lot of SQL, a lot of databases, there were a slew, and there still are a slew of reporting tools that are meant to just build grids and forms with very little actual software development involved, software engineering. And a lot of developers were also forced into it because, again, like you build a backend, you have to provide a user experience, and now you have to do it. A lot of people, that's not what they wanted to do, but to make their product valuable, they had to. If you're a Java or C# developer and you're forced into using those technologies that you really don't want to, you might start growing a negative sentiment about it. There's also, again, like if I follow that thought, there's very much a clash of backgrounds from other ecosystem. You have like the Java developers, the C# or Visual Basic developers, the Ruby devs, and so on, that are all coming together because they have to target a common platform. The front-end JavaScript and browsers ecosystem are kind of lowest common denominator that everybody has to target. They might not want to. That's not what they signed up for. A lot of these languages have static types. They have higher construct like classes that until ES6, were not in JavaScript. And from their background, like I fully believe that you can build powerful front-end applications with a dynamic language like JavaScript. Things like TypeScript and Flow are coming. Well, they're more than coming. They're pretty pervasive at this point. But even without them, while they're nice tools, the JavaScript and front-end ecosystem were plenty powerful enough to do what we needed to do with them. But if you're from a background where you actually think it's mandatory, this is not even up for discussion. Until, again, TypeScript and Flow, JavaScript was the language you had to target, and there was no room to disagree like there was on the back end, where you could be a Java dev, but you could also be a Ruby dev. And this is not completely wrong that there was a lot of chaos in the ecosystem, a lot of growing pain. These days, if you're working in React, which is my favorite, that's great, but if you're picking Vue.js or Angular 2 or something, those are all pretty solid frameworks. You'll be able to build anything you actually need to build with them. It's very much a case of preference. A couple of years ago, though, I'm not sure I could have said the same. There were very large differences between, let's say, Backbone, Angular 1, and React, and the one you picked could really have a deep impact on the total cost of ownership of your code base, on the cost of development, and which kind of features were easy to build, which ones were hard. There was a lot of churn in module system. It's easy to forget that Node, Webpack, Parcel, and all of these are kind of recent in the grand scheme of things, and it was only a couple of years ago where before ES6 modules we had CommonJS, we still do, but they're pretty similar. But before that there was AMD, and before that there were like we used globals with namespaces and various different, like every framework had their own ways of doing it, so you kept having to learn new ones. There's also like I don't want to say a war, but there's different pushes depending on developer background between functional programming and object-oriented programming technique, because JavaScript supports both. And mixing and matching can be a good strategy, but it can cause some friction. And there's always all the asynchronous programming patterns in JavaScript, promises, callback, RxJS with observables, async and await, and that can cause a lot of confusion, especially for people that are coming from other environments. There's also was a pretty long, slow growing pain towards single-page application. The web, originally, it was built to make web pages and was a platform really for documents. Today, we're obviously no longer using it just as that. We're trying to push it much further. For a while, a couple of early adopters started building these highly complex, highly dynamic applications pushing the platform to its limits. And a lot of organizations and companies and developers saw these, wanted to do the same thing, and when they tried, realized it was really hard. In the days of Internet Explorer 5 and 6, before all these bundlers and modern frameworks were a thing, you had to do everything from scratch. The performance was just not there. The language was not where it is today. The libraries were not. Um, there was like a big transition between the features that were expected from desktop application, trying to replicate that from the web. Ajax was not as common as it is today, and it was misunderstood. All around, it did not feel like the platform could really support what you were trying to do, but your competitors were doing it, so you really didn't have a choice, and you had to keep banging your head against that wall. And this part might be a little controversial, but one of the biggest strengths of front-end development is that all you really need to do it is a browser and a text editor. Anybody can just pick those up, make a web page, write a bit of JavaScript, and they have a fully running app. That makes it a fantastic environment for newer developers to go in, and the community has done a lot to make it as accessible as ever. Initiative and projects like Create React app let you have an almost production ready app with just a single command. But when you have, like, again, this clash of culture and backgrounds, and you see an ecosystem where the majority, or I think I can say the majority of developers are less experienced, if you're trying to be very negative, you see that and say something like, all these people are not real developers, they don't have computer science degrees, they don't have years and years of experience, they don't know how to build an enterprise application. And you can use that argument to kind of dismiss the entire ecosystem as a toy or a joke, even though really, since software is becoming so important to every facet of the world, you want as many people as possible to be able to work on it, else you'd never be able to scale. So these developers of today are your coworkers of tomorrow, and that's a wonderful thing. But again, some people will use that in a negative way, which is unfortunate. So why does it matter? How is it hurting you, your product, your organization, if people don't treat front end seriously? Well, there's a lot of ways to look at it. Some of the reason you could be considering to push for changes at your company. First, if you're working for an organization where the front end, like a public web app or something, is the product you're trying to sell, well, it's going to be the face of your company. It's going to be how people judge you. That there is millions of lines of code behind it does not really matter for a customer. They just want to be able to use your product and do their job. So if you provide a subpar experience or you don't invest properly in it, it's just going to hurt the company as a whole. If you're building tools for internal users, maybe you're working in a department that builds apps to support your company's own employees, well, this is still going to be what people work with every day, every time they come to the office, and that's going to hurt company morale, right? If the tools they have to work with are just not great. If the front-end developers don't have seat at the tables, then it's not going to be part of product management and product planning. The front-end aspect of the product are going to be pushed at the end and rushed. And again, you're not going to be able to create a quality product. You're going to have an organization where managers, the people that are evaluating you as a front-end developer, might not be able to appreciate your work. You might be working all evening or all week on this super cool, nice CSS animation, and that will make like the product and experience so much better. And then when your manager look at it, they're going to be like, yeah, it's an animation, anybody could do that, and you're just not going to be rewarded for it. In the same vein, you're gonna have missed opportunities and missed promotions if people can't appreciate how difficult and how multifaceted your front-end development and your like all the stuff that you've learned and built as part of your career. If they can't appreciate that, when comes time for a raise or to grow into your role, you might be dismissed, and a back-end developer might get those opportunities instead. Generally, you're just not going to be in a place where you can get the resources that are required to create the product your customers deserve. Building a full-featured, rich, accessible, performant web application in 2019 is a lot of work, and you need the time and you need the people to be able to do it. A little bit of a pet peeve of mine, but I found that in these organizations, all bugs just become front-end bugs. Since again, your customer, when they look at your product and they see that the page does not work, they don't really care that it's the database behind it that's down or that the API was poorly designed. They just see that the page does not do what they want to do. When they report the bugs, in those organizations, they'll all go to the front-end developers. They'll have to diagnose them, debug them, figure it out, and then once they found the root cause, pass it already pre-crunched to the people actually responsible for the root cause. Obviously, there are real bugs on the front end, but having all of them go through you instead of having like an organization culture that everybody's responsible for those bugs and work together to resolve them is really going to hold you back. So how do you fix this? How can we make an organization better, a place where front-end developers can thrive and where front-end products can be developed with all the resources they need? There are people problems and there are technology problems for this that need to be solved. Let's start with the people problem. So first, and that's probably going to be one of the most controversial things that I'm going to talk about, but it's split the front end and back end. That is, make front end have dedicated front end developers, dedicated back end developers, make them work together on the same product. As you grow, make dedicated front end teams and dedicated back end teams that will both have front-end tech leads and back-end tech leads and front-end managers, back-end managers, and so on. By doing that, you're going to have a higher level of transparency between who has what expertise. You're going to manage expectations because both back-end development and front-end development have reached a point where being an expert in both is incredibly difficult. Being an expert at React, at the latest and greatest of CSS, accessibility, performance, and internationalization on the front end, and being an expert at databases and system designs and queues and AWS and servers and all that stuff, having all of that in your head is really a lot. By separating them, by splitting them, you're going to be able to specialize and be much more efficient on both. But also, you're going to ensure that people, again, will have the proper expectations and that they can grow in their roles doing what they're truly best at. Definitely consider the impact of full stack developer. The analogy that I like to give, I'm a big gamer and I'm always thinking of it in terms of a role-playing game where, let's say, you have fighters and you have wizards, and maybe you can be a fighter and a wizard at the same time, and that's super nice, especially from like a management point of view where you can use somebody to do anything. No matter which challenge you give them, you don't have to think about their specialties. They will be able to tackle them. But if you think about the app as in her RPG term, as a dragon, well, if you're both a wizard and a fighter and you're not specialist at both, then your sword is probably going to miss, not able to hit the dragon, and your spells might not be high level enough to hit the dragon, and then the dragon here is a metaphor for the state of the heart of the technology. You won't be able to achieve it. While if you have like someone who's like the best fighter they can be or the best wizard they can be, they're going to you're always going to have the expertise you need to do the job. But then unfortunately you will have to think, when you're planning your projects, you'll have to think about the front end dev has enough time to do this at this point in time. The back end dev has enough time to do this at this other point in time. So it's more difficult for a management point of view, but you can push the state of the art much further. Also, be careful when you're doing this about branding someone as a front-end developer because they just can read a little bit of JavaScript and CSS. I see this in a lot of companies where, let's say, a Java developer will come in and will, on their resume, they'll have that they work a little bit on the side on the front-end dev or on the front-end app, or at their previous company, they were helping with the front-end. Maybe that's not what they actually want to do, and they just had to. If they want to do it, that's one thing, but often they were pushed into it, and that might just not be what they want to do or what they're good at. If you're a hiring manager and you're trying to hire front-end developers, it's very challenging. There's a lot of demand, and so whenever somebody sees that's a prospective hire has that expertise, they might want to put them in those roles right away, but that might not be the right thing for that person. Now, kind of completely opposite to this point, but there should be one career track and a set of titles for everybody. And by that, what I mean is, if you're a really big company and you have multiple departments, you might have different ways to talk about software developers. It might be web developers, it might be engineers, and so on and so forth. But and that's okay. But if you have multiple people working on the same product as part of the same group, and some are front end and some are back end, be extremely careful about having like the back-end developers be software engineers and the front-end developers be like web developers or something. That's pretty important, because if you start splitting the titles, you're going to risk having heavy bias when you're judging the impact that people are going to have. If when you're giving raises you have two different titles, they might very likely have different salary bands, and they might have, obviously we talked about how like you want front end and back end to have expectations that match the stack they're working on, but when they're judged for promotion, you want them to be able to be judged about the impact they're having on the product and on the organizations, not about some arbitrary salary track just because they have a different title. You'll want leaders, tech leads, managers that have front-end background. What I mean by that is I found that in a lot of organizations, to become a tech lead or to become a manager, you need to be either full stack, which frequently just means someone that understands data and backend and just so happen to understand how a web app works, or maybe you need to know nothing technology speaking at all, and you just need to know product. There's a couple of issues with that. When and I've touched on it before, when your tech lead or your manager looks at your impact, if they don't fully understand and appreciate the challenges of front-end development, they're not going to be able to truly judge how well you're doing in your role. They could underestimate it. They very much could overestimate it too, which has its own problems. So I want to challenge people to consider what their definition of a tech lead or an engineering lead is. certain organizations have the concept of like tech leads that are really software engineers who can call shots from a technical point of view, and managers that decides on promotions and do career development and stuff. But there is a school of thought that you really want your manager, your boss, the person that's calling the shot on if you're doing well or not in your role, to be someone who could do your job. That does not necessarily mean they'd be as good as you at it, or that they could truly do everything you could do, but someone that at the very least, in a pinch, could understand the technical challenges of the code you write. And if you really want to have front-end developers that are specialists at this, to be able to judge and appreciate that work, you'll need managers that also have a high level of understanding of front-end development. Now, something else that I want to speak of is how you should use the same source for talent for front-end and back-end. As companies are growing and as the technical scene is growing and as we're trying to scale our organizations, a lot of companies are finding that hiring just computer science majors from a handful of universities they're familiar with is no longer cutting it. It's not enough for diversity to build teams that have a higher, broad set of skills and talent, but it's also just not enough in terms of numbers either. So these companies are starting more and more to look at people without computer science degrees, people who are self-taught, people with alternate backgrounds, people who come from coding boot camp. And in many cases, that's working out quite well. One thing, though, that can be problematic is because front-end development is seen as a place that's easy to enter and very accessible, all the people that are coming from alternate paths are frequently all shoved in the front-end stack. There's a couple of the front-end track, sorry. There's a couple of issues with that. First, if you have a limited amount of mentors in your organization, you want to help these people grow into senior engineers and to be as impactful as possible at your company. If you have, let's say, 5 front-end mentors and 5 back-end mentors, and you're putting all the entry engineers on the front-end track, you're going to have overloaded front-end mentors. These people will no longer be able to also contribute to code nearly as much, while the back-end developers and those really strong people that could have been mentors are not mentoring anybody. They're not helping anybody grow, at least not entry-level engineers, and they have much more time to contribute, which in the short term is going to benefit them a lot, and in the long term means you're going to be struggling to find talent. I've just a little anecdote, but I've worked with someone once that had gone through a coding boot camp, and they came from a field that was very data-centric, a lot of number crunching, even though it was not software engineering. And really, they were not very successful as a front-end developer. They didn't have a knack for user interfaces. Technologies like React and CSS did not excite them. And they started having kind of an imposter syndrome and wondering if that career change was a good idea. Giving them another chance and teaching them, like we found that this person did a lot better when they started working more on the back end, and they really thrived. And if it was somebody that could have learned like from a boot camp to code in a couple of months, making them learn just a couple extra skills so that they can work in a different environment should just not be that hard, and they might thrive a lot more. So again, be careful to all shoehorn entry-level developers all in front-end development. You don't want kind of a self-fulfilling prophecy where the front-end part of your organization is much more junior and hurting for mentors. Front-end teams should have some ownership of the product. It's really important when you're planning projects, when the product managers and tech leads and stuff are getting together, that the leads of the front-end teams, the representative of the front-end teams, also have a seat at the table. You want to be able to properly scope what it is to build the front end for your product. Make sure you have enough time, make sure you have enough people. What you don't want is a type of project management where all the data and the backend and the APIs are built and then are handed over to front-end developers. And maybe the APIs are not built the way that a front-end developer would have needed it. Maybe they're not optimized. Things like paging and counts and stuff might not have been thought of. And then at that point, the deadline to actually ship the product is getting close. Your front-end developers are going to have to take those APIs and make miracles with them, which means they're going to have to work overnight, they're going to have to deal with less resources, and generally the product's just not going to be great. Consider the front end to be its own features, its own, it needs its own timelines, it needs to be prioritized properly, essentially. You'll want to create a culture where front-end technologies have an identity, and that requires a bit of explanation. Consider that there are a lot of challenges unique to front-end technology, and you want people in your organization, leaders and stakeholders, to understand this. You're going to be writing a lot of code that runs on other people's computer. You don't control the runtime. It's going to be running in browsers. You might not decide which browser they're going to pick. They might decide to use Internet Explorer, and there's nothing you can do about it. Consider that you can't abstract the UI away from the end user. If you have a database and you have an API, you can abstract flaws or quirks of these parts of the system with the next layer in front of it. But once you build a front end, you can't abstract that away. That's what the user is interacting with. If it's not good, the user sees a substandard interface. You can't build something on top, maybe with the iframe or scraping / proxying it, but really it has to be good. I mentioned earlier how, from a customer point of view, all bugs become front-end bugs. You also have a lot of challenges like localization and accessibility, which can be seen at all part of the stack, but are really like a big part of building a front-end product. You want to make sure, again, that the leaders and stakeholders are familiar with what makes a good front end, what makes it challenging, and how to build a great product. If they don't, you'll have to keep reminding them until they do. You'll also want, as part of giving front-end its own identity, to code JavaScript like it's JavaScript. And again, here I'm going to have to extrapolate a bit. Sorry. The JavaScript community is really complex. You have a lot of developers, like I mentioned earlier in this talk, that have diverse technology backgrounds. They might be former C# dev, they might be former Ruby dev, they might have started with Node and JavaScript. Idioms don't always translate from an environment to the other. Historically, I was a C# developer. I did some Java too. Even though those two languages are extremely similar, there are small things that completely change how you think about it. How C# has public properties as a first-class citizen, and Java use getters and setters. That might change how you code. Essentially, what is factual in one language and that you take for granted just isn't always true in another. These languages, C#, Java, are based on classes. JavaScript has first-order functions, and you can make a module that does not contain a class at all. And again, that might change how you think about it The performance characteristic of the language can be completely different. These are all things that you need to think about, and you don't want to just code JavaScript like it's C# or something. I want to give an example, and I'm going to use probably the least controversial keyword in JavaScript, the class. I've mentioned it a bunch already. And the goal here is not to do a flame war of functional programming versus OOP or anything like that. It's just a very easy example to give. So consider like an API class / module like this, a class that has a bunch of static methods that you just call when you want to do these actions. I've seen this type of class a lot in many code bases. Well, this is probably how you'd code something like that, a utility class or an API class or whatever, a singleton, in a lot of modern programming languages. But is that really how you do it in JavaScript, given all the JavaScript tools you have at your disposal? Consider that in JavaScript you have access to ES6 modules, which is a construct that might not be available in other environments, and that's why they do it that way. But in JavaScript, you could just do this. You can make a module and just export a bunch of functions. A module is already a singleton because in JavaScript, every byte that you're shipping over the wire is really important. Having statically analyzable imports like this is going to help, like with dead code elimination and tree shaking. Now you might consider, but what if I need multiple instances of a class? Well, JavaScript has very powerful closures, and you can just return anonymous objects. So if I want, I can just make a function that return one of those objects with these methods, and it's just going to work, and I didn't need a higher level concept like a class. And what about inheritance? Well, inheritance can be a pretty powerful and complicated concept that's really hard to replicate with other technique. However, a lot of the time, people just want an object and they want to tack on extra methods or override methods on it. And in JavaScript, you just have object.assign or object spread syntax, and it's just going to do what you need. Again, you don't need more powerful concepts here. And what about private variables? You could wait until the TC39, the organization that pushes changes to the JavaScript standard. You can wait for the private instance variables to become part of the standard and ship with browsers. Or you can just use, again, a closure, and that works today using just normal functions and just normal returns. There's nothing more to learn about that. There's a lot more things like that to think about. If you consider TypeScript, which while it's not like standard JavaScript, it's a great type system that was built with JavaScript development in mind, especially with the features they added to it in recent years. But when you will use TypeScript, consider that it's not C#, even though it could look like it. For example, it has structural typing instead of nominal typing. Basically, the fact that an interface that has a couple of properties will match any object that has the same properties. They don't need to actually say that they implement that interface. And that can change a lot on how you write your code. Things like dependency injection, if you've done, again, a lot of C# in Java, that's something that's pretty common, and there is some in like environment like Angular. But do consider that in a world where every byte matters, having one file where you define a lot of your dependencies might not be the right way to go, and a lot of dependency injection systems that are ported, if you will, from those other languages to JavaScript actually do it that way, and they're very hard to code split. Again, consider things like Node is not like Ruby or Python and stuff. The same holds true for CSS, HTML, and the rest of the front-end ecosystem. I'm just giving JavaScript examples there to keep things short. But essentially, you want to try to use the tools at your disposal and not make the assumption that what you've learned somewhere applies as is, and definitely don't assume that it's just a fact. Figure out the best way to solve the problems you're trying to solve, rather than just blindly using the techniques you're used to. Now we've mentioned how the ecosystem can be pretty chaotic and that people come from various backgrounds. That means there's going to be a lot of bike shedding going on, and the front-end world is notorious for it. So for those not familiar with the word, because I will use it a lot, bike shedding basically just means going back and forth on decisions or arguing about a lot of little things. When you're debating if you're going to go between spaces or tabs for your indentation, you're bike shedding. If you're debating between using classes or functions, you're bike shedding. So there's a lot of options in JavaScript and the front-end ecosystem, and people will bike shed them a lot. You'll need to make sure your organization grows into a healthy one. You'll need to solve that problem. You're going to be hiring a lot of really smart, really strong engineers with a lot of experience. They will not agree on what's the best way to build a front-end application. So the first thing I'm going to suggest is that you agree on some core engineering values. Whenever you're going to make a decision, you're going to have a couple of ideas in the back of your mind as to what's important. Depending on the stage at which your company or your organization is, if it's a really big one, a really small one, a startup, or whatever, that's going to influence a lot on what's the quote-unquote right way of doing things. Maybe you're at a place where you're focusing on performance and it's the most important thing to you. Maybe you're focusing on building an MVP of your product, a minimum viable product, and developing as quickly as possible, and maybe taking a hit on quality is what you agree on. Different people, if you don't make this clear, will argue with these kind of core decision in mind, and two people might debate and try to optimize for different things. And if that happens all the time, you're wasting a lot of time. So here's some examples of core engineering values that you should make explicit in your organization, document them, and every time a big decisions need to be made, refer back to them. Some example that I personally really like, but really you have to pick the ones that fit your organization. But one could be pick one and stick with it, or essentially that it's better to be great at a single technology than to always use the right tool for the right job and have 10 technology that you all need to understand. Maybe a value is that you have a lot of teams and you want to make sure that moving engineers from one team to the other does not require relearning everything. So that means that you'll want to pick fewer technologies or not necessarily allow every team to bring in different frameworks. Maybe one of your core values is continual deployment, continual integration, and you're going to be shipping several times a day. So you're going to need tools that allow you to build really fast, a lot of automation around testing, and the way you're going to build your application should never require slow builds. Maybe one of your core value is that every decision you make must benefit the customer in some way. So you will not bring technologies that are only there to make a developer's life easier if there's not a measurable customer impact. These are, again, just ideas and examples. They might not fit your organization or your scenarios. Agree on a couple of values like this, and once again, refer to them every time there's an argument and people are trying to debate between multiple solutions to a problem. Next, you'll want to avoid NPM-driven development. I'm going to have to explain what it means. NPM is probably one of the biggest, if not the biggest, package manager in terms of how many packages it contains. It's very easy to build a front-end application by coding very little. Every time you hit a problem that requires a non-trivial amount of code, you probably can Google and find a third-party library that will do what you want. You can assemble these like Legos to build an app. That can sound great. I mean, owning less code is better, right? Well, that has a lot of issues. First, you're going to have a lot of libraries that you might not actually understand. You're going to have to debate between which one is the best. Is this drop-down library the best? Is this other one the best? They're going to have bugs. You're going to have to decide if you work around them, if you just don't build a feature that would hit that bug, if you're going to work with the open source maintainer to fix the bug. You're going to have issues with bundle size, where maybe you're pulling a library and just trying to use a single function, and the way the library is built, you're going to be pulling hundreds of kilobytes of JavaScript. You're going to have a lot of stuff to document, a lot of stuff to read when people are trying to understand why that, like where that complexity of your app comes from. Your app might have very little code on its own, but when adding up all the npm packages, there's a lot, and a new engineer joining has to learn how all of that work. I highly recommend that you consider the trade-off of writing up things yourself. Sure, if you're trying to build a calendar component and you're not in the business of making a calendar app, you might not want to write that yourself. It's really complicated. But a lot of the code that people pull in npm packages for is really trivial and simple to write on your own. Think about like a bunch of Lodash methods where you could just use ES6 or something. By writing your code on your own, you can tailor it to your own use cases. You never have to worry about breaking changes between major versions. You don't have to argue about the best way to do things unless you're arguing about the implementation itself. And you're going to have much finer control about your bundle size and how to make things fit into the rest of your architecture. In the same vein, when we're talking about libraries, you don't have to keep upgrading everything. Have you ever seen these calendars that they sell around Christmas time that like has a little door for every day of December, and kids open a door every day and there's a chocolate behind it to help them wait until Christmas? I feel a lot of front-end developers like use a calendar like that when counting the days until the next version of React come out, or until the next version of their favorite library is published. And the moment it comes out, they just feel that they have to upgrade right away. Now, don't get me wrong, when React hooks came out, I was probably one of the first to push to upgrade React right away. But consider that if it's not broken, you don't need to fix it. A lot of the sentiment in the front-end community that it moves so fast and that it's so chaotic is because people feel forced to always upgrade to the latest version. When a new version of React Router comes out and it has some breaking changes, people get really frustrated because they feel they're now forced to fix them right away. But the old version of the library might not have stopped working. You still understand how it works. Your implementation still works. Your product might still be in production. Don't upgrade it. In other environments, it's very common to skip a major version out of 2, to wait a year plus before upgrading. And then you can have a much more stable application that you understand much better, and you have more time to actually build features or build more quality into your product instead of just spending time upgrading all the time. Now, I also want you to be careful about using words like boilerplate and dry, don't repeat yourself, when talking about front-end code. We hear a lot about that, for example, in the Redux world, where you have to write a bunch of actions in a reducer and connect them and all that stuff. People don't like that, and as engineers, we're almost conditioned to see replicated code and immediately start looking for a way to abstract it, a clever pattern, a library, or another framework on top. You quickly end up with a place where you have much less code, but nobody knows what the code is doing, especially newer developers, and then you need to document it, and people need to start reading those abstractions, which are much more complex and than just writing the code where it needs to be. Copy pasting code is frequently a valid way to do code reuse, and then when use cases change, you don't have to start adding more arguments to your abstraction and have if-else statements all over the place. When I look at a Redux reducer written with a vanilla JavaScript switch, I can read from top to bottom and I know exactly what it's doing. If you're using a clever abstraction on top of it, it might look nicer, it might be prettier, but I'll have to now go and understand what the abstraction is. Be careful though, because there is a point where not abstracting anything is going to start causing your bundle size to inflate. And that is a valid reason to start abstracting some stuff. But don't use dry as a goal. It's a solution to a problem that you can responsibly apply to these problems, but don't say, I made this because dry. You really need a better reason than that. You're going to want to decide how you're going to agree on ESLint and prettier configuration. I don't mean agreeing on the rules. I mean agreeing on how you'll agree on the rules. An example is I push a lot for having prettier. By the way, in case you're not familiar with it, prettier is an automatic JavaScript code formatter. I push a lot for prettier to be used for all aesthetic and formatting concern. ESLint, a linter that's basically analyze your JavaScript code to find issues with it, can be used for aesthetic and formatting changes, but I prefer delegating it exclusively to rules that would find bugs in your code, like usage of undeclared variables, for example. There are things that Prettier does not do that are aesthetic specific and that ESLint could potentially do. And one rule that I like to set myself is to not use ESLint for that. That way, when someone is like, can we enable this rule or not, you're not opening the Pandora's box. Once you open the Pandora's box and you let people add in any rule they want, there's going to be a lot of arguments, people that like these rules, people that don't. If you have an objective way of agreeing on them, this rule that we are adding will prevent an outage eventually, for example. That makes it a lot easier, and there's going to be a lot less churn in your ESLint rule. And Prettier is really good for the formatting stuff. It does mean that you'll have to swallow your pride, and some formatting things will not get enforced, and that's okay. Just ignore them. Now, this one's probably my favorite, but again, as your organization grow, people will want to make changes to the way you do things. You don't want to be in a place where changes never happen. You don't want to be in a place where you're static and people are afraid of change. But you also don't want people to just constantly suggest to change everything. Especially as you hire people, you might have agreed on something for specific reasons, and the new person that comes in does not have the full context, and they'll suggest that thing again. Even though you had all agreed not to do it. If your organization is really big, there might be nobody to explain why that decision was made, and then that decision will get reversed, and then all the problems you were trying to prevent and that you had agreed on preventing will happen anyway. So what I really like is using an RFC process, a request for comment process. I like using the way Yarn or React do it, and I'll get to that in a bit, to force people who want to change things to explain their motivation, go into more details on why they do it, and allow people to comment and debate it in a format like a GitHub pull request or a Dropbox paper, in a way that will be able to preserve this for history. Then when later you hire somebody and they ask questions about why something is this way, you can just link them the document and they'll have all the history and all the context instead of repeating these arguments. So an example of how you could do RFC documents could be making people write up a summary of the change with some basics examples of what like the new pattern would look like or something in code. They would have to explain the motivation behind the change. Why is it that what you currently have is not good enough and why we need to change it? They'd have to add a detail of the architecture and the designs they're suggesting. You want them to explain what are the drawbacks so that they can really think. There's only trade-offs in software engineering. Like nothing is a slam dunk. You want people to consider the alternatives. Again, there's multiple ways to skin a cat. What will be the adoption strategy? How will we migrate to this? How do you teach it? For example, I'm a big ReactJS fan, and I think we should use it. But most people are familiar with promises in JavaScript. They might not be familiar with observable. And then when you have to teach this, you're going to need to explain to people how to use it, how to debug it, and you have to coach newer developers. There is a cost to that. And of course, there's going to be unresolved questions, and that's where the request for comment comes from, so that multiple people in your org can pitch in. Once you have the document and that it is approved or disapproved, you can save it with the conclusion, and then everybody will have access to it. Now to move on to how you could build a front-end infrastructure group in your organization. I mentioned a lot already how front-end is now a deep and complex field for software developer. I think it's no longer reasonable to expect a front-end developer to know everything there is to know about how to build their apps. The person who is an expert in accessibility, internationalization, and UI might not be the person who's an expert in CDNs and S3 and build tools and Webpack. A lot of these concerns are horizontal across building features. They will impact all front-end developers. If you build a front-end organization, you will allow people to become specialists into what they need. Maybe they're going to be a specialist in building features in X part of your app, or maybe they'll be a Webpack specialist, and that will allow you to push your expertise a lot further. You'll want to start small with just having the tool. Start with building the tools to make this happen, then eventually making people specialize into it. And as you grow bigger, you can have entire teams around it. So there's a couple of pillars of front-end development that I consider pretty important. So again, you'll want to start small and invest in those pillars, grow specialists and grow specialties there. These are areas to focus in, not necessarily things that you'll want to staff with an entire team right off the bat. So you'll probably want to consider that eventually. So the first one, and the place I'd start with, if you can only invest a few people or a few hours into it, is a core team. They'll want to be responsible for build and deployment, And when you're small and just starting, they'll also be responsible for everything horizontal, like all your tool, how your best practices, linting, deployment, all that stuff. When you grow even bigger, though, they'll definitely stay specialists in things like Webpack or Parcel that you're using. They'll be dealing with your continual integration and continual deployment infrastructure. I also want you to make a decision about how you're going to manage your repositories. There's a lot of stuff in the community about the advantages of monorepos versus distributed repositories. I personally think both can work and both are great. I don't think either of those is the way to go. The only thing is you don't want to do both. Pick one and stick with it. Again, consider that building a React application and building a build pipeline are two completely different skill sets. This team is going to be able to specialize in the later. The next thing you'll want to invest in pretty quickly and pretty early is a design system. Now, at HubSpot, I'm not responsible for a design system, so I asked Julie, the tech lead of our front-end infrastructure UI team, what's her definition of a design system. And this is what she told me. It's kind of like a style guide of what colors to use, typography, etc., combined with a reusable component library, combined with real documentation and a process to maintain it and keep it alive. I'm going to show exactly what it means in a moment, but this is going to help you stop reinvent the wheel or stop you from building a 10th date picker or modal window. It's going to prevent you from solving the same problems over and over. It's going to elevate everyone's thinking to focus on actually solving the customer and not picking how many pixels the padding or margin should be. It's going to let everybody focus on getting good at what they do. It's going to bridge the development and design world. On the front end, you want your developers and your designers to be tight-knit. And this group, this area of expertise, and eventually this team is going to be able to bridge the gap between the two. It's going to also significantly help your customer because your UI is going to be so much more consistent. I asked one of my friends who's building this app. He's a solo person working on that, and this is what he showed me. He had to always think about colors and margin and all that stuff, even though he was only a single person with no designer. And he spent a couple of hours and built this small design system, and that saved him a ton of time. You can start with something like that, and then as you grow, start building component libraries and documentation and everything else. But you don't have to start big. Performance and reliability. Consider that perf and reliability is a feature. It will affect your bottom line. It will affect your NPS score. Be careful of even in the MVP stage, you don't want to prematurely optimize things, but you don't want to be feature, and end up with a 20 megabyte JavaScript bundle. Consider very early in your development cycle to have SLAs and budgets for your bundle, what you consider an app to be too big. Figure out how you're going to measure page performance. A lot of tools out there just check page loads using the browser's API, but you have to ask the question, when is your page actually loaded? Is it when the frame is there? Is it when the report in the middle is loaded? Is it when all API calls are finished? You'll have to answer that question and make your tools use it. Build a checklist. Not everybody's going to be an expert at performance. Build a checklist of things to check and do with your apps to keep it fast. Make decisions with data. There's a lot of misinformation out there. Things like server rendering might have performance benefits in some cases, but not in all cases. Don't do it blindly. You could be spending a lot of time for nothing. Get to terms with the fact that performing code is not always pretty. A lot of those fancy abstractions will have a cost, might be slow, and sometimes you're going to have to write what looks like bad code to help your customers. When you start building a team around this, make sure they are advocates and will push really hard the rest of the organization to keep thinking about performance and reliabilities. And really, don't ignore your bug reports. It's so easy in front-end development to look at Sentry or New Relic and say, oh, these errors are just noise, we can't explain them. That will happen. It doesn't always happen. Next, internationalization. If you're building a product, chances are you want as many customers as possible. And while it might be a surprise to some, the US is not most of the world and not even close, no matter how big it could be. You'll definitely want to have dedicated engineers here. A lot of problems are really difficult. Something that I learned a while back was how first name and first and last name in the US, like for me, will be François Word, but in certain countries, certain culture, it should be written as Word François. Or if I'm trying to be less formal, I might just write François, but in certain culture, that's completely unacceptable. As a front-end developer, that's just one example, and there's so many to think about. I will not be able to do it right all the time or even know about it all the time. When you're adding things like time zones, currencies, and all that stuff, it's just too much. This can be kind of an extension of your design system and component library. You can write components in React or something to handle this for you. So you're going to need software engineers who specialize in this and keep track of all that stuff. You'll want them to be advocates for a culture where your app is built for everybody beyond just accessibility. It's really a specialty on its own. These are the people that are also going to build relationship and link translators the same way the design system folks are a link to your designers. You'd want to consider performance implications of this too, because as you're if you were to load all your language instead of code splitting and selectively pulling the right ones, that's going to have an impact. Or if you're pulling all your time zone data and stuff. I want you to consider not waiting too late to start thinking about this. Sooner or later, as you grow, you'll need to make your app in multiple languages, even if your initial customer target, as you're building a minimal viable product, is really small and you're only starting with English. It's just not that hard to extract your English strings so that they're not hard-coded in your app. Just pick a library and then do it or something. It might even make your code better, so that when your boss comes to you and asks you to translate everything, you're not starting to search for strings all over on a multi-year project. If they're already extracted, you can start with just translating those. There's going to be a lot of other challenges when it comes to time zones and stuff, but you'll at least have a solid footing to get started. Consider building a lot of expertise around testing. Consider the difference between a manual quality person, quality specialist who's going to be manual testing, an engineer in test that might be writing testing tools and stuff for their product and teams, and an actual engineering team that are building testing infrastructure. All of these are super useful and super valuable, but in this context, I'm talking about the later. You want an organization where you're going to build tooling to support making the product developers write tests. There's a lot of ways to test code. There's unit testing, the kind of test that you're writing as you're building a feature. There's integration testing, making sure that things work okay with each other, or testing bigger components of your app. And end-to-end testing, which is usually automation and actually running the real app to make sure it all works. All of these require kind of a platform to build on. You're going to need tools like Jest for unit testing. You're going to need something like Selenium or Cypress to do the end-to-end stuff. And it's hard to be a specialist in that, even though I highly recommend that the people who build the feature should be the people writing the tests. Selenium is really not that bad. It's just that when you're on a deadline and you just finished building a feature, now's not the time when you want to start learning about the quirk of a pretty complex tool. But if you have specialists in that, you're going to be able to better support your front-end engineers. Definitely be careful about your browser support story. More and more people are starting to test only in Chrome. You don't want to be in a place where if a user is using a different browser, nobody tested it. When you come and pick what tools you're going to build your test suites on, make sure that they support the browsers you actually want to target. Also consider visual regression. We were talking visual regression testing. We're talking about challenges that are unique to front-end development. Well, front-end has a UI. It's very possible to have a front-end that shows the correct data, but maybe a margin or padding is wrong or stuff shifted to the left only in Firefox. That's really time consuming to test for. And there's a bunch of tools like Percy, like Screener, and various others that will help you catch these kind of bugs and save you a ton of time on testing. Consider tying this infrastructure with the design system. Something that can be cool is if, as you're building components, you're building utilities to automate these components, it's going to be a lot easier to write tests. Selenium and Cypress are really good at clicking on a button or entering text in the text field, but if you have like a rich drop-down or a rich calendar component, it can be really hard to find the right way to manipulate them and automate them. If you're building utilities around it, you're testing your design system, and you're providing the tools for developers to automate their app for testing at the same time. A little further, and probably not the first thing I'd invest in, but still amazingly valuable, and I fully consider it to be one of the pillars, is developer experience. You're going to want, as you grow, to have a good onboarding, good documentation, good patterns on how to share code, good standards. You're going to want to fully integrate with the editors people use. You're going to want your linter and code formatter story to be solid. You might need generators to automatically generate code. That's a lot of work, and it very quickly becomes a full-time job. Having a developer experience group that are going to spend their time on this instead of just being an afterthought for people when they have a couple of hours on the side is really going to make your developers much more productive. Also consider the experience of code migration, and when like you're finally actually upgrading libraries and stuff, having people who are really good in things like code mods and static code analysis and stuff, who will be able to automate a lot of that instead of having someone painfully doing it manually. And the sky's the limit. If your organization becomes really big, a lot of these groups can be split even further. Maybe you'd want a backend like developer group to be able to build APIs and stuff to power some of the tools that these teams are going to build. Maybe like a design system is generally contains like low-level components that you could build any app on, but maybe you're going to start building like higher level things that hit APIs that make things like uploading files easier, maybe stuff on top of GraphQL, and that could be its own specialty too. The sky's really the limit. There's a million more things you could do. Make sure to balance out your investment. If you do everything I've just talked about too early, your developers are just going to go so fast that the business is not going to be able to keep up with it, and you're going to have even more growing pains instead of less. You'll want to balance out. Make sure not to take all your strong developers and put them all in these teams, because then you'll have nobody left to actually build the features that are using this, and you're not going to get your return on investment. All right, that was a lot. Let's wrap it up and bring all this together. If you want to build a front-end organization that you're going to be proud of, really you'll want to start with people. You're going to solve to want to solve the bike shedding problem and all the decision making and argument issues. Remind people that front-end technologies have their own challenges and their own strengths, and that it's important to consider that during project management and during planning. And you'll want to invest in individuals or groups that support the rest of your front-end organization, because it's just too much to expect everybody to know everything. You'll want to grow into this, to keep things simple, don't fix what's not broken, balance out your investments. And that's it. Thank you, everybody. On the slide, there's my contact information. Feel free to reach out, and I'd love to know how this is working out in your organization. Again, thank you.